talk quadratic formula. So there's pieces of the quadratic formula that are pretty cool. There is this piece right here. Why am I still talking over people? Thank you. Notice this. What's this? What does negative b over 2a give us? Axis of symmetry. So it tells us, sorry, can somebody please stop doing that with the pen? Thank you. It gives me an axis of symmetry. I guess I should also have actual graph. This is better. All right, it gives me an axis of symmetry. All right, this part right here talks to me about my roots, and that's what we're going to do first. This tells me what type of roots that I have. So if I say, here's an example of a related function, so here's a function, how many roots does this one have? 2. So 2 roots. 2 real rational roots. What does that mean to be 2 real rational roots? How would I get 2 real rational roots? I give you a quadratic equation like this, and you come up with 2 rational roots. What does it mean to be rational? Not just on the number line, you're close. Those are integers. But the rational ones are the ones where you can also express them as a fraction too. So in other words, it doesn't have a square root, okay? Those are the irrational. Irrational roots are when you have a square root and you can't rationalize it. You put that in a calculator and it's going to be not repeating, right? But something that has an irrational ending, or it's not ending. It doesn't repeat on a decimal. So 2 real roots would be, I could basically factor this. I'm going to write that over here. So I can factor. But remember some of those that we couldn't factor? At first I was talking about them being out here, not touching the x-axis, and then I took that back and said, no, if we can't factor it, it can also have roots, but those roots would be irrational. They'd be fractions or decimals. Same thing, right? All right. So what about this one? How's this different with this graph? There's 1 root. So what would we say about something that was only 1 root? What are we going to say about this? Can't factor. If I can't factor, do you guys remember what you would use? No, because if x box, you would be able to eventually factor. But if it's not factorable, what would be your next step to find roots? Oh, that's by graphing. Brandon? Quadratic formula. Can't factor, so the quad formula. All right, what about this one? What's happening when I get something like this example, with 1 root? Nobody? I'll give you a clue. It is factorable. So how is this one different than this one? 1 root. What would that look like factorable? Okay, not the difference of 2 squares, the other one. It's called a perfect square trinomial. So it would come out perfect like this. A plus b squared. Right? That would give us only 1 root. And finally, what about this one? How many roots does this one have? None. How do you think we get those? Not only is it not factorable, but when we go to use the quadratic formula, there's something very interesting that happens. Here's a clue. We did it yesterday. It doesn't stay with the square root. That would be an irrational root. It's got imaginary numbers. How do we get imaginary numbers? Where do they come from? Negative roots. Exactly. So if I go to use the quadratic formula and I end up with a negative root, that means there's going to be an imaginary number there. And we're going to have no roots. Okay, so not factorable. Then we use quad formula. And we discover a negative underneath the square root sign. All right, so check this out. You can use the discriminant to analyze your graph, like this. So b squared minus 4ac is greater than 0. For instance, let's use let's use 25, or I'll use 5 squared minus 4 times 1 times 2. What is that? (25 minus 8). What's 25 minus 8? 17. So if I got an answer of 17 when I used b squared minus 4ac, that would tell me I would have 2 roots. You know, I was going to write them down here on the side. I think I'm going to skip this part and go straight to it because I think it makes more sense. So if b squared is greater than 0, but not a perfect square, you're going to get irrational roots. If b squared minus 4ac is equal to 0, you're going to get 1 root. And what do you think this one is? So this is greater than 0, equal to 0, and less than 0, right? Because if it's less than 0, it's going to be a negative number. So if it's a negative number, you're going to end up with complex or imaginary roots. Make sure you have all that down, and then let's talk about it. Because I'd like to have it on your paper, let's, on second thought, let me write this down. If you end up using the quadratic formula and you get x equals -5 plus or minus root 25 over 5, do you see how the 25 would be a 5? Right? And you'd get an actual number. It would be -5 plus 5 over 5 and -5 minus 5 over 5. 2 roots. This one, thank you. This one would be something like this. -5 plus or minus the square root of 24 over 5. If you got something like that, you'd have to leave the square root in there, right? And there's really nothing else you can do with it except for simplify that radical right there. That's when you get answers like that where the radicals still stand. This one, I would get -5 plus the square root of 0 over 5. That means that doesn't mean anything, right? The square root of 0 means nothing, so I would just get -5 over 5, which is just -1. So that's how I get only 1 root. Because you don't have 2 options. Plus or minus means 2 answers, right? But when you have plus or minus 0, you no longer have two answers. You only have one. Does it make sense? And this one would be -5 plus or minus. I get a negative sign in there. And as soon as I see that negative, I know that it's going to be complex roots or imaginary roots. Questions so far? Let's just dive in. All right. So complete parts A through C for each quadratic equation. I'm going to do 4, one of each. All right. This one's going to be pretty straightforward. All right. So find the value of the discriminant. First of all, before I do anything, I always want to consider the behavior of this graph. Where is this graph intersecting the y-axis? -16. Good. So x squared plus 6x minus 16 equals 0. So down here. Is this a smiling graph or a frowning graph? It's smiling. So I may not know how it's smiling yet, but it might be like that. It's got to have two roots, right? Doesn't it have to have two roots? I know that for sure, because since it's at -16 and it's pointing up, it's got to cross that x-axis twice. Okay, so find the value of the discriminant. A lot of kids think the discriminant is the square root of b squared minus 4ac. That's not the discriminant. The discriminant is only the b squared minus 4ac part. The square root is part of the quadratic formula. Make sense? Okay, so when I put b in, let's see, we have a equals 1, b equals 6, c equals -16. So b squared would be 6 squared minus 4 times 1 and -16. 36. What's 4? -4 times -16. Positive 64. What's 36 and 64? 100. So the discriminant is 100. What does that tell me? What does that tell me? Two roots, one root, or no root? Two roots. So I'm right. Okay. So let's go back and use the quadratic formula. Yes, sir. I'm going to show you right now. Because the discriminant is greater than 1. I'm sorry, greater than 0. Remember, greater than 0, two roots. 0, one root. Less than 0, no roots. And specifically, I know I'm going to be adding and subtracting 10, because when I take the square root of 100, I'm going to have 10, right? So it's going to be real rational roots. Okay, so this quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a, which is x equals. All right, so let's start substituting in. X equals -b plus or minus the square root. The nice thing about this is when you find the discriminant first to figure out the behavior of your graph, that work is already done. Okay? I already did the b squared minus 4ac part. All over 2a. All right, so b is 6 and a is 1. X equals -6 plus 10 over 2, or x equals -6 minus 10 over 2. Where did I get 10 from? The square root of 100 is 10. So if we continue with this, you get 4 over 2, which is 2, or -16 over 2, which is -8. Those are my roots. Specifically, 2, 0, and negative 8, 0. I will no longer accept this on a test right here. I'm going to take points off if you don't put this. 2 and negative 8 is not your answer. 2, 0, and negative 8, 0 is your answer. It's a spot on the graph, right? Where what? The spot on your graph, point on your graph, where what? Where it intersects with the x-axis. That's what we're finding. I'm not a stickler about the mechanics as much. I'm a stickler about the big picture. Because I think that's how you get away from memorizing things. You just learn what it means, and then you don't have to memorize it if you can think about it, right? Okay, questions on any of this so far? Yes, sir. Right here. We did the b squared minus 4ac first so we would know that it had 2 roots. Yes. Is it possible to get the y-intercept? It's always going to be 0 when it's crossing the x. See how it's not up on the y or down on the y? It's always 0. Does that make sense? Hey, look, it's negative 8. I did pretty good, huh? You see what I'm saying, Brandon? It's always going to be, x-intercepts are always 0. And y-intercepts always have x as 0. Because it's intercepting y and it's not even reacting with x at all. We got the y-intercept right here from this part of our equation. That's where the y was. Negative 16. And that's because if I plug in 0, 0 squared plus 6 times 0 minus 16, I get negative 16. That gives me 0, negative 16. See how the y-intercept is the 0 as the x? Make sense? Okay, fantastic. You can even start, Brandon, in the very beginning of writing a shell like this and say, I already know that this is going to be 0. Okay? Alrighty. Let's move on. You want to try this one? Is this the same? No. Looks the same for a second. I'm curious, how many of you can look at this and tell me what the roots are right now? How do you know that? Because what? I want you guys to discuss it for a second. All right, I'd love to hear some answers and some justification. I don't mean to record this. We'll come back to it. Alrighty, so after our discussion, we discovered that it is a perfect square trinomial. So I'm going to first look and see what happens with the discriminant. So b squared minus 4ac. B is negative 16. I'm writing a little bit too small. A is 1. C is 64. What is 16 squared? 256. And 64 times 4? I'm guessing it's 256, which equals 0. When I have 0, I don't have two answers anymore, right? Because when I use the quadratic formula and I get a b plus or minus, this answer in there is going to be 0. There is no more plus or minus. There's just one answer. And b is negative 16. So therefore, I get positive 16 over 2, which is 8. So, thank you. Positive 16 over 2 is 8. See? They're coming together like you're seeing it. The big picture, not just negative b plus or minus square root of b squared minus 4ac all over 2a. Like, who wants to do that and then be blind when you're doing it and cross your fingers that you got it right? You know what I mean? Wouldn't you rather understand what it means? And then you can catch it right here. First of all, you can look at it and know if you're right or wrong. All right, let's try another one. Let's see. A equals 3. First of all, do you look at it and see that it's going to be factorable? It doesn't look like fun, does it? All right, let's look and see what's the behavior. Here's a graph. It's up, and what else can I get from this? The y-intercept is 1, so it's right here. Right? If it's up here, I cannot say at this point that it's going to cross the x-axis. It could do this. Right? I don't know yet. All right, so let's find out. How would I find out if it's going to cross the x-axis or not? Not just solving it. There's a piece of it that's going to tell me. So b squared minus 4ac is going to tell me whether or not this thing crosses the x-axis or not. Also, have you guys been looking at this? The negative b over 2a part is your axis of symmetry. Right? So it's like the quadratic formula is really not this crazy thing. It's your axis of symmetry and then your roots. Those things together, axis of symmetry and roots, which makes sense because the axis of symmetry is based around the roots, right? So you put those two things together and it's not such a strange formula after all. All right, so this one's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, why did I do that? You don't want to do that, right? That's more work. I mean, it's not more, but we'll put the b squared up here. Minus 4ac. I want to talk about it before I do it. All right, so b is 5, a is 3, c is 1. 25 minus 12, which is 13. This is 13. What am I going to have? How many roots? 2 roots, right? It's either 2, 1, or none, right? So let's find the rest of it. B is, we also know it's not going to come out real pretty, right? As soon as you get a number right here that's positive and it's not going to be a perfect square, you know that it's going to look like one of these nasty things right here. So at least when you do the problems, you'll know from the very beginning whether it's going to be a long one or not, you know? Okay. You still have to do it. All right. You know what it does help with, though? Whether or not, which method you want to use. Whether you want factor, whether you want to use the quadratic formula, because there's lots of different ways to do it. All right. So this is 2 different answers. X equals negative 5 plus the square root of 13 over 2, or X equals, it's not or, it's and. I don't know why I keep saying or. Oh, thank you guys. 3, 6, thank you. Negative b minus the square root of 13 over 6. If we put that all in a calculator, it's going to be a decimal. I know. Let's approximate. Negative 5 plus, I don't know the square root of 13, but I know the square root of 16. 4. So negative 5 plus 4. Negative 1 over 6. Small, right? It's actually somewhere around 0.2. Or I could have, do you want me to say 1/6? Was it negative 1/6? Negative 1/6. This one, square root of 13 is somewhere around 4. Negative 5 minus 4, negative 9 over 6. What's negative 9 over 6? Negative 3 over 2. So on your graph, it's going to be negative, like right there, and then 1.5. So it's really steep, which makes sense because doesn't it cross at 1? Looking at the whole behavior of the graph. So write down as much of that as you want. 2, 1. All right, last one. b squared minus 4ac, b squared minus 4ac. First of all, is this going to be smiling or frowning? Smiling. Y-intercepts at 10. I don't know what's going to happen. You know it's going to be, what? No. I told you I was going to do one of each. So what's this one going to be? Up in the air. I like it. All right, so B is negative 6, A is 1, C is 10. 36 minus 40 is how much? Negative 4. I get a negative. That means I'm going to have a negative under a square root. That means it's going to be imaginary roots. So x equals negative b plus or minus the square root of negative 4, right? All over 2a. A is 1. So my two roots are negative 1 plus. Now help me out here. You guys can all do this part right here. Oh, thank you. Why am I making all these mistakes? Thank you. Positive 6. 6 plus, what's this? 2i over 2, and x equals 6 minus 2i over 2. Are we done? No. Why? I can simplify it. How? Dominic, how? Okay, so tell me what I get. Over here. 3 plus I and 3 minus I, right? When I take a 2 from everybody? Do you guys need to write this down still? Give you a sec. I have a question about putting it in coordinates. The answer to this would be 3 plus or minus I comma 0. You could write it that way. Or you could write it 3 plus I comma 0 and 3 minus I comma 0. Right? Imaginary root. Okay, so try and memorize it. If the discriminant is greater than 0, I know what? It has 2 roots. If it's 0, it has 1 root. If it's less than 0, it has no root. The person next to you is absent. How would you explain when you should use the quadratic formula? How would you explain it when you have to use the quadratic formula? If you can't factor, fantastic. Good job.